Hi students, in this video we're going to be talking about graphing sine and cosine. We're going to be limiting ourselves to just the vertical transformations to kind of understand how those affect our graphs. We're going to have a separate video for just horizontal transformations and a third video for putting those pieces together all at once. Alright, so for our first one, we've got a graph of y equals 3 sine of x, and we're given y equals sine of x on this paper. And by that I mean the screen. What I'd like you to remember is that if we have something that we're multiplying times the function itself, this is a vertical stretch. And this would be a vertical stretch by a factor of 3. In trig terms, this is going to be our amplitude. So instead of going up 1 from our midline, now we're going to be going up 3 from our midline. So this point would, instead of being at a height of 1, be at a height of 3. Zeros are unaffected by vertical stretches. So when we're talking about vertical stretches, we're going to be with reference to the midline. And the midline here is going to be at a height of 0. For mother functions, that's always going to be where we start. And again, I'm multiplying the max and the min by 3, so that we're going down to negative 3 and up to positive 3. This gives me a graph shape that's 3 times as tall as my graph originally was. And at this point, we're done. If this had been cosine, the graph would have been exactly the same type of transformation, but it would have been shifted a little bit to the left of where this graph is. Speaking of cosine, if we are going backwards from this, so we're trying to write a function for this, and right now the only thing we're talking about is figuring out what that a value is. And what I notice is that my midline, the middle of this graph, is at 0, and that I'm going up 2 and I'm going down 2 from there. That means that I'm stretching my graph out by multiplying by 2. Another way to think about that is that a value is equal to 2. So this would be y is equal to 2 cosine of x. The next parameter we're going to talk about is what happens if I'm vertically shifting instead of stretching. And again, I'd like to remind you that if I'm talking about a function where we're adding some number to the end, this is a vertical shift. So this connects back to what we're doing in transformations. And in terms of trig terminology, this number is all about the midline. So my midline used to be at 0. Now it's going to be at 4. 1, 2, 3, 4. First thing I want us to do is always draw that new midline in. All right. For cosine, I'm going to be starting at the top, and we're given the mother function here. So that's going to be 1 above the midline. My next point was going to be on the midline, and then 1 below the midline, back on the midline, and 1 above the midline. So it's the basic cosine shape, and we are applying that to graphing this midline, and then graphing the cosine function itself. At this point, this problem is done. All right, I'm going to look at the next one, which we're given. This is a sine function. I'm going to draw my midline on here, and I notice that my amplitudes are 1 and 1, so this is the basic sine function, but the midline has been moved down 1 from 0. Because of that, this is going to be the equation y is equal to sine of x minus 1. So what happens if we have these two things together? So we're trying to identify y is equal to 3 sine of x minus 2, and we're given just the graph of y equals sine of x. We can do this in terms of transformations. I'd like us to note that this whole graph, based on thinking about transformations, would be a vertical stretch times 3 and a vertical slide down 2. But in terms of trig terminology, we identified that last number, what we're moving it up or down, is the midline. So y equals -2 is going to be our midline. And I'm going to draw that across here. All right. So y equals -2. The next thing we're going to look at is the number in front. And if a equals 3, that's our amplitude. The way that I'm always going to draw these functions is I'm going to use that amplitude and sketch some more lines. So if we're going at -2, if I go up 3, that's going to be a +1. I'm going to draw another line up here. That's going to be the upper bound of my graph. And going down 3 from -2, I love when it doesn't fit on there. That's -5. It's going to be at the bottom of my graph. This is like when you were learning how to write letters in like kindergarten, and you had that paper that had the 3 lines on it so it'd be easier for you to connect to. We're going to do the same type of thing here. We know that this graph shape is going to be the same as what we have for the basic sine function. And sine, I'd like you to notice, at the beginning, the end, and the middle, is going to be on the midline. So I'm going to include those 3 points. That's at 0, -2. This middle one is going to be at pi -2. And the one at the end is going to be at 2 pi -2. Okay, so then we need to talk about the points that are in the middle. And what I like about graphs of sine and cosine is that I can go right in the middle of 0 and pi. And that's going to be at pi/2 because that's exactly between 0 and pi. The top of my graph is going to occur exactly in the middle of my first 2 midline points. This is going to be 3 up at pi/2, comma 1. And looking at my graph so far, we've got that first curve. It looks like it's down and it's been stretched out. So that makes sense to me. For my next point, okay, I'm at the bottom. That's going to be exactly between those two. I know between 1 and 2 is 1.5. It's 3 pi/2. And it's going to be at the bottom of my lines. This is the point 3 pi/2, comma -5. So we're going to go down, and then we're going to go back up to get to our midline again. I'd like you to notice this has the basic sine shape. We've identified the midline, we've identified the amplitude, and then we've used that to graph 5 points. Whenever you're asked to graph these things or work back from these things, you're going to be asked to do these same things. Graph 5 points and show these calculations. Going backwards, the first one, because I'm starting at the top, going down, coming back up, that looks like a cosine function to me. So I'm going to call this cosine. I'm going to just quickly identify the period. How far is it going from the top to the top? Going from 0 to 2 pi is going to be 2 pi. That's the normal period, so we don't have to worry about that. You might also have gotten that from that's not what we're talking about in this particular video. I don't have a phase shift because I'm starting at 0. Again, not part of this particular video. And my midline is going to be at -1. And then my amplitude going from the midline to the top is going to be 1, 2. That gives me some stuff for my equation. So we've got y is equal to, my amplitude is 2. My function itself is going to be cosine of x. And my midline is going to be -1. Because we're not dealing with any horizontal stuff, we don't have to worry about the stuff in the middle yet. That's going to be the next step that we do. For our second one, because we're starting at the middle and going to the middle, this is going to be based on y equals sine of x. If we had more information, you could pretty easily do a cosine equation for this as well. In fact, you could from this picture too, but it would be a little bit harder for us to work with. Same thing, my period going from 0 to 2 pi is 2 pi, so we don't have to worry about that. Again, we knew that going into this. My midline, where these points are all lining up in the middle, is at 2.5. That's going to be plus 2.5 at the end of my equation. We already said this is going to be a sine of x. Let's talk amplitude. So for the amplitude, we're going from 2.5 up to 4. That's 1.5. And then we have one other thing going on. Sine of x has this shape where we go up and then down and then back up. The graph we have here starts going down and then goes up and then comes back down. This is flipped upside down of what sine of x would look like. So this is going to be negative 1.5 sine of x plus 2.5. I'd like to remind you that the transformations we talked about earlier this year and that you talked about in Algebra 2, a negative out front flips this thing vertically. So that's where that comes from.